Now we go hands-on with the workspace. This section covers creating and configuring AML workspaces, connecting data stores, setting up compute targets, and locking it all down with identity and access management. This is D1, the most tested section of the infrastructure domain. There are 3 ways to create an Azure ML workspace: the portal, the CLI, and Bicep. The exam tests the CLI and Bicep paths because they're the ones that matter for automation. Let's walk through both. CLI first. The command is AZML workspace create. At minimum, you need -name for the workspace name, -resource group for the target resource group, and -location for the Azure region. If you don't specify storage, Key Vault, and App Insights resources, Azure creates new ones automatically with default names. In a real production deployment, you'd pre-create these supporting resources with your own naming convention and link them with -storage account, -key vault, and -application insights flags. The CLI is idempotent. Run it twice with the same parameters, and the second run is a no-op. For Bicep, and this is the D1, 3 path the exam loves. The resource type is Microsoft.Machine Learning Services/Workspaces. The required properties are name, location, SKU, basic or enterprise, though in practice you choose standard, and properties containing the IDs of the associated storage account, Key Vault, App Insights, and optionally contain a registry. The workspace resource in Bicep is where you set public network access, enabled for dev environments, where you want easy access, disabled for production, where all traffic must come through a private endpoint. The kind parameter is a newer addition, and the exam is testing it more as Foundry gains adoption. Default gives you a standard AML workspace. Hub gives you a Foundry hub, the shared infrastructure layer for Foundry projects. Project gives you a Foundry project, the team-level workspace inside a hub. In Module 4, we'll dig into hub and project deeply. For now, know that when you're creating an AML workspace for MLOps work, the kind is default. One exam trap. The friendly name and description properties exist and are useful for governance in large organizations, but they're optional. The exam may include distractor answers suggesting these are required. They're not. Name, location, and resource group are required. Everything else has a default or is optional. Creating the workspace is step 1. Configuring it for production use is step 2, and this is where many teams cut corners that hurt them later. The AI-300 exam tests workspace configuration as part of D1.1. So let's cover the 4 configuration areas that appear on the exam. Tags. In enterprise Azure environments, tags are not optional. They're how finance allocates costs and how governance teams audit resources. Every workspace should carry at minimum 3 tags: environment, dev, staging, prod, team, the owning team name, and project or cost center. You set tags on the workspace at creation via CLI with -tags nv = prod team.ml platform, or in Bicep under the tags property. When an exam question asks, how do you ensure ML compute costs are attributed to the right team, tags plus Azure Cost Management is the answer. Diagnostic settings. A workspace without diagnostic settings is flying blind. You connect the workspace to an Azure Log Analytics workspace, choose which log categories to capture, and from that point on, you have queryable logs for every compute event, job event, and endpoint event. The 3 most important log categories for the exam are AML compute job event, training job lifecycle events, submitted, running, completed, failed, AML compute cluster event, cluster scaling events, and AML run status changed event, run status changes for monitoring. These logs feed your alerting rules. Workspace compute quota. Separate from subscription quota, you can cap how much compute a given workspace can consume. If you have 3 team workspaces sharing one subscription, you don't want one team's runaway training job consuming all available cores. Set max cores at the workspace level via the CLI or portal. This is a guardrail, not a bill. If a workspace hits its quota, jobs queue rather than failing. Managed virtual network. This is a newer workspace security mode that the exam is picking up. Instead of manually configuring a VNet and private endpoints, you set the workspace's managed network mode to allow only approved outbound, and Azure ML manages the network rules. In this mode, compute can only reach resources you explicitly approve, no arbitrary internet access from training jobs. This is the recommended mode for regulated workloads. Know the three modes: basic, no managed network, allow internet outbound, allow only approved outbound, strict allow list. It's lab time, and this first one gives you the foundation everything else in the course builds on. You're going to provision a complete Azure ML workspace from the command line using the Azure CLI, not the portal. The CLI, because that's how production workspaces get created in CI/CD pipelines. And that's what the exam tests. Here's what you'll do. First, create the resource group and the three supporting resources: storage account, key vault, and app insights with controlled names. Then create the workspace and link those resources. Then configure diagnostic settings to forward workspace logs to a log analytics workspace. And finally, apply the standard enterprise tags. By the end of this lab, you'll have a fully configured workspace that you'll reuse in labs 2 and 3. The PDF lab guide is attached to this lecture. Download it, open your Azure subscription, and let's go. Before you start the lab, here's a quick reference for the key CLI commands you'll use. They're all in the PDF guide with full flags, but this slide gives you the skeleton. AZ group creates the resource group. AZ ML Workspace provisions the workspace. You'll add flags for the pre-created storage, key vault, and app insights. The diagnostic settings command is longer. Use the guide for that one. When you're done, AZML Workspace Show confirms everything is wired correctly. And the cleanup command at the bottom, run it when you're done with the module to avoid compute charges. One important note: the cleanup command deletes the entire resource group, including all resources inside it. So only run it when you're finished with all 3 Module 1 labs. The lab guide gives you a per resource cleanup sequence if you want to keep the workspace for Module 2.